Hi, this is Dr. B. Ravi Chandra. Today, in the last session, in the last lecture, I have discussed about introduction to digital signal processing, followed by the first topic, which is related to the signals and what is meant by signals, what are the classifications of signals, what are the discrete elementary signals, some different types of signals we have studied in the last class. In this lecture, we are going to discuss what is meant by system, and then followed by properties of discrete Fourier transforms, and related to that properties we will solve some different types of problems. Now first starting with what is meant by a system. Starting by what is a system, then classification of discrete time systems, properties of discrete Fourier transforms, and related problems, which is so starting with what is a system. We know that in the last class we have discussed about signals. So we came to know that a signal is nothing but a physical quantity which is used to transmit the information from source to destination, and that signal consists of some different types of information, whatever it may be, related to the electricals or electronics. It carries up some information from source to destination. Fine. Now how this signal is going to transmit? What is the source which is used to transmit the signal from source to destination? So here comes the system. The system is nothing but it's a physical device. It's a device which is used to transmit the signals from source to destination. So you can see here the basic block diagram of the system. System process input signals. That means the signals what we are giving, it process to produce the outputs at the destination side. So a system is a combination of elements. It's a combination of blocks that manipulates one or more signals, whatever it may be. It may be one signal or two signals or more than one or two signals, some different types of signals to accomplish a function and produce some output. So it's a device which consists of some different types of blocks that is used to transmit some signals. It may be a one signal or different types of signals from source to destination. So you can see here the input signal, whatever it may be, it is given to the system where it produces the outputs of the signal. So a system is a device which is used to transmit the signal from source to destination. Now depending upon that systems, here the systems, discrete time systems, are classified into some different types. So for which is nothing but static and dynamic systems, causal and non-causal systems, linear and non-linear systems, time invariant and time varying systems, stable and unstable systems in detail. So first starting with static and dynamic systems, what it is saying, you can see the statement. It is a memoryless system. It is a memoryless system is one in which the output at any instant depends only on the present input. So what here, a static or memoryless system. So a system is said to be a static or memoryless when in which the output, you can say that the output, which is nothing but y of n, is at any instant depends only on the present input, that is x of n. So at that instant and not on past or future inputs. Okay, the output will depends only upon the present inputs. Here you can get the examples which is related to the static and dynamic systems. You can see here the output y of n is completely depends upon the input x of n, but not on the past or future inputs or outputs. We can see here there is no future inputs, no future outputs, and no past inputs and no past outputs. That means the outputs will depends upon only the present input. One more example you can see here. Y of n is equal to 2x square of n. That means it is depending only on the present input. So that's why we are calling it as a static or memoryless. Why? Because only current input na, so it cannot able to store the data which is related to the past or present inputs or past and present outputs. That's why it only depends upon the present inputs. That's why we can say that it has a memoryless system. So followed by the vast, that means in contrast, in the opposite, a system is said to be a dynamic or memory system, which it depends, if the response depends on the past or future inputs or past outputs. That means it depends upon the past inputs, future inputs, as well as past outputs. You can see the example, that is, you can see here y of n is equal to, it is depending upon the present input x of n and also past output input, that is x of n minus 2. And one more thing you can see here, y of n plus 4y of n minus 1 plus 4y of n minus 2 is equal to x of n. So it is, we can see here, it is depending not only on the present input but also future inputs and fast inputs as well as the past outputs. So it is the first discrete time system, which is nothing but the dynamics and static systems. Coming next, which is causal and non-causal system. So causal system, when we are going to say that is a causal system, here also you can see here it is a non-anticipative system, is one where the output at any instant depends only on the present and past inputs but not on the future. You can see here the output y of n will only depends upon the present input. I can say present input is nothing but x of n plus past inputs x of n minus 1, so on, or else, but it will not depends upon the future inputs. You can see here one example. You can see one example here. Y of n is equal to n into x of n. That means it is depending upon the present input. Or else you can see here y of n is equal to, it is depending upon the past input and present inputs. Okay. So now it is very clear that a system is said to be a causal system or anticipative system when the output depends upon the past and present inputs but not on the future inputs. So in opposite, a system is said to be a non-causal or anticipative if its output at any instant and depends upon the future inputs. So here it is depending upon the present and past inputs, and coming to the non-causal system, it only depends upon the future system. So it is said to be an anticipatory system. They produce on output even before the input is not given. One more thing in this non-causal system is it will produce the output. Even if you are not giving the input, it will produce the output. Due to some external effects, it will also directly produce the output without giving the input. You can see the example. Y of n is equal to x of n plus x2 of n. Only present inputs. It is depending upon the only present inputs, that is x of n is one present input and x of 2n is another present input. One more thing, you can see here y of n is equal to x square of n plus 2x into n plus 2. That means the present system is said to be a non-causal system when the output depends upon the future inputs only but not on the past and present inputs. Okay, so this is said to be a causal and non-causal system. Coming next, it is linear and non-linear system, which is very important. It says that a system which obeys the principle of superposition. It is very important. You need to keep it in mind that the principle, a system which obeys or which follows the principle of the superposition and principle of the homogeneity. If a system following these two conditions, these two principles, then that system is said to be a linear system. And a system which does not obey the two principles, then it is said to be a non-linear system. You can see the example, homogeneity property. What is the homogeneity property and what is this superposition means? You can see here an output y of n for an input x of n must produce an output a y of n plus for an input a x of n. So directly you can see it will be very clear that by seeing this particular equation, see here the input a x1 of n plus b x1 of 2, it should produce a x1 of n plus b x2 of n. Okay, so this is the principle of the superposition, or else it is a principle of the homogeneity. If the system is following these particular conditions of particular principles, then that system is said to be a linear system or non-linear system. It is very important. And the final one, which is shift invariant and shift varying system. The name itself is telling shift invariant. It is shifting, varying system. So what it says, a discrete time system is said to be time invariant or shift invariant. Shift invariant if its input or output characteristics remains unchanged over time. In other words, the behavior of the system is not dependent on when an input is applied. So it is clear when we see this mathematical definition. So I am taking the input signal x of n, which produces the output y of n. That is, so I am giving the signal x of n to the particular system and I am producing the output y of n. So then for any time shift invariant for any time shift k. So k time shifting, if the input is delayed by k time shifting means it is going to delay for k times. The output should also be delayed by the k times. So it is clear, you can see here in the input side it is k times delay, that is x of n minus k, which is shift invariant by k times it is delaying, If the input is delaying for the k times, automatically the output should also delay for the k times. That is, transposing of the input signal x of n minus k should produce the output same y of n minus k, which is very clear that if the above condition holds for all the values of k, then the system is said to be a time invariant system. Clear? When the input is shifting for any number of delays, the output should also shift in the same manner. So if it is not occurring, then I can say that it is shift time invariant system. Okay. And finally, stable and unstable system. This is also very important when coming to the in upcoming classes. What it says, a system is said to be a BIBO, that is bounded input and bounded output. When that means if it is a BIBO, then we can say that system is stable. That means if every bounded input produce the bounded output. So by seeing this particular, you can see here the bounded input x of n less than or equal to mx. In that particular system, the bounded input, we need to get the bounded output only. So apart from that, if the system produces the bounded output, then we will say that it is a unstable system. That means mod x of n less than or equal to mx. In this bounded input, the output should be also in the mod y of n less than or equal to my. Okay, in these conditions only, when the input is given at that particular bounded only, we need to produce the output. So then that particular system is said to be a stable system. So it is for all the values of mx and mi for finite. Fine. So this is all about the classifications of the discrete time systems. Fine. So based on this particular thing, let's start what is the Fourier transform and what are the properties of the Fourier transform. Today, these are the main properties which we are going to discuss, followed by linearity properties, periodicity, circular time shift, time reversal, circular frequency shift, multiplication or modulation, circular convolution, and Parseval's theorem. These are the main thing. These are the main properties of the discrete Fourier transform. So before going to this, we need to recall the equation of the discrete Fourier transform. That is, if x of n is equal to summation n is equal to 0 to n minus 1 capital X of k e power minus a 2 pi by n into kn. So based on the particular discrete Fourier transform, these all properties are going to prove. Fine. First one, linearity property. Already we have seen what is linearity property. What it says, what is the statement it says? The two inputs, that is x1 of n and x2 of n, are in finite duration. If I take the DFT of x1 of n, it should produce x1 of k. Similarly, if I take the DFT of x2 of n, it will produce the x2 of k. So based on this particular statement, what it says, for the real valued or complex values, when I take the discrete Fourier transform of a x1 of n plus b x1 of 2, it should produce a x1 of n plus b into x1 of 2. So based on this particular thing, we will just prove this. I am considering this particular thing, that is DFT a x1 of n plus b x2 of n, by considering this RHS. So I am writing first, I am writing summation a x1 of n is equal to summation n is equal to 0 to n minus 1 a x1 of n plus b x2 of n into e power minus j 2 pi n k by n, which is the DFT, discrete Fourier transform equation. So I am separating these summations. So this is the first term, that is x1 of k term, and this is the second term, which is x2 of k terms. So we know the general equation for the discrete Fourier transform, if it is summation n is equal to 0 to n minus 1 x of n e power minus j 2 pi n k by 1, I can directly call it as x1 of k. Discrete Fourier transform will be converted to x1 of k according to this particular thing. Similarly, df2 x2 of n is nothing but df2 x2 of is nothing but x2 of k. So finally I can say that DFT of a x1 of n plus b x2 of n is equal to a x1 of k plus b x2 of k. So this is the linearity property. The next one, which is the periodicity property, what it says, if a sequence x1 x of n is periodic with a periodicity of n samples, then n point DFT x of k is also periodicity of n samples. That means x1 of n is periodic with the n samples. The produced DFT x of k should also be a periodic with the n samples. That means, what is saying, x of n plus n, if I am giving x of n plus capital N is equal to x of n. Similarly, what it is producing? X of n with n samples period, it should produce x of n. Similarly, if I transmitting x of k with n samples, it should produce x of k, periodicity with n samples. So what you can see here, I am considering the discrete Fourier transform for x plus nth term, k plus nth term coefficient I am taking. So according to the DFT condition, x of k plus n is equal to summation n is equal to 0 to n minus 1, x of n e power minus j 2 pi k plus n, n by n. So here I am e to the power of a plus n. So I am separating it e to the power of a into e to the power of n. Now you can see this particular term is in the form of x of n, total x of n. So I can write this particular thing as 1. Okay, I'm writing this particular thing as 1. So what I'm going to get? I'm going to get summation n is equal to 0 to n minus 1 x of n e power minus j 2 pi k n by n into this term is nothing but equal to 1. Now if we see this particular thing, it is in the form of x of k. Okay, it is in the form of x of k. So on the left hand side, if the kth plus nth coefficient of x of a, then what I'm going to get? I need to get the, for n samples of x of k plus 1, I need to get x of k, which is proved. So it is nothing but the periodicity property. Now circular time shift. What it says, circular time shift, the name itself is telling it is somewhat very important, and the related problems will be discussed in the upcoming slides. The circular time shift property of DFT says that if a discrete time signal is circularly shifted in time by m units, keep it in mind, m units, it is shifting circularly, then its DFT is multiplied by e to the power of minus j 2 pi k n by capital N. That means what is saying, DFT of x of n minus m, that means m units time it is circularly shifting. What it should produce? It should produce x of k with the multiplication of e power minus j 2 pi k n by capital N. Okay, now we will see that. So consider inverse discrete Fourier transform of x of n. I am taking the equation of IDFT x of n, which is nothing but 1 by n summation k is equal to 0 to n minus 1 x of k e power minus j 2 pi k n by capital N, which is the generalized equation of the inverse discrete Fourier transform. Now what I'm doing here, I'm keeping n is equal to n minus n naught. In the place of n, I'm substituting n is equal to n minus n naught. So x of n minus n naught is equal to 1 by n summation k is equal to 0 to n minus 1 x of k e power minus j 2 pi k n minus m by capital N. Okay, a small modification here. I'm keeping n is equal to n minus m. Okay, small modification. So in the place of this n minus m, I'm replacing it with n minus m. So same, I'm dividing this exponential form e to the power of a into e to the power of minus a. So here we are going to get this term will be equal to 1. So what the thing I am going to get here, 1 by n summation k is equal to 0 to n minus 1 x of k e power minus j k m by n. So this total time I am directly writing it as x of k. So I am taking DFT on both sides. So DFT of x of n minus m is equal to DFT of x of n into e power minus j 2 by. I am taking two discrete Fourier transform on both sides. So finally what I am going to get? I am going to get DFT x of n minus m is equal to x of k into, it is multiplied with e power minus j 2 pi k m by n. So what it is saying, DFT of if x of n is circularly shifted by m units, what I should get x of k e power minus j 2 pi k m by n, which is proved here. Fine. So this is the circular time shift. How much time it is shifting? It is shifting m times units circularly. The next one, time reversal. Followed by this time reversal, what it is saying, reversing the endpoint sequence in time is equal to reversing the DFT sequence in the x of n is equal to x of k. What it is saying, DFT of x of n minus small n, reversing endpoint sequence. What should I should get same reversing of endpoint with k. So DFT of x of n minus n is equal to x of n minus k I should produce. So what similarly I am taking here DFT of x of n minus n, DFT equation I have taken, instead of small n, I have substituted that n minus n. So in the place of n minus n, what I am taking here, m is equal to n minus m. So n is equal to n minus m. So here I need to concentrate on the limits. First n is equal to 0 I am substituting, so that I am going to get m value is equal to n, and if I am substituting n is equal to n plus 1, then I am going to get m is equal to 1. So with this I can show you here what I am going to get, summation m is equal to 1 to n x of m e power minus j 2 pi k by n of n minus m. Same, I am subtracting this exponential, and the first exponential will be equal to 1. So what the term I am going to get here, I am going to get only this term. So for this I am writing it as, here I am going to get 1, okay. So if I substitute, if I divide this exponential e to the power of a minus m, e to the power of minus a into the e to the power of minus m, so this particular time I am writing it as 1. Instead of 1, what I am writing here, I am writing e power minus j 2 pi by n into nm. So for why I am writing that, why I am writing like that means, to get that particular equation into k minus n into m. So if you see here, summation n is equal to m is equal to 1 to n x of m e power j 2 pi by n k minus m. So DFT I am going to get x of n minus k, which is a time reversal system. Similarly, circular frequency, what it says that the circular frequency shift property of DFT says that if a discrete time signal is multiplied, if a discrete time signal x of n is multiplied with e power j 2 pi l n by capital N, it circularly shifted by L units, okay, it should circularly shifted by L units. That means what is saying, if the discrete time signals x of n is multiplied with e power j 2 pi l n by capital N, what should be produced? It should produce the circular shift. How much time, how much units? L units. That is, this double bracket indicates circular shift, x of k minus l. How much unit is it is shifting? L units it is shifting. So for this multiplication of discrete time signals, what should I produce? It should produce capital X of circularly k minus 1 into n. So we will see, we are considering the DFT equation, x of k is equal to summation n is equal to 0 to n minus 1 x of n e power minus j 2 pi k n by capital N. So what I am taking here, instead of k I am substituting it with k minus 1. So x of circularly shifting now, how much units? L units it's shifting. That is x of k minus 1 into n is equal to summation n is equal to 0 to n minus 1 x of n e power, instead of k I am writing it as k minus l. So same, separating this exponential time, and this particular exponential will be equal to 1. So what the remaining term I am going to get, summation n is equal to 0 to n minus 1 x of n e power j 2 pi ln by n. So totally this I can write it as DFT of x of k e power j 2 pi ln by n. So what it is saying, the discrete time signals, if it is multiplied with e power j 2 pi ln by n, what should I get? I should get x of circular shifting of L units with n. Okay, so that is which is nothing but the circularly frequency shift. Circular convolution, it is very important where we should keep concentrate on this. Why? Because we will get some different types of problems related to this circular convolution. It is somewhat very close to that of multiplication. If we see here, if I am considering the discrete time sequence 2, that is x1 of n into x2 of n, what should I produce? I should produce summation n is equal to 0 to n minus 1 x of n, x2 of circularly convolute n minus m into n. So what's the statement says? The circular property or convolutional property of DFT says that DFT of circular convolution of two sequences x1 of n into x2 of n is equivalently produced of their individual DFTs. So individual DFTs. So what it says, DFT of x1 of n into x2 of n is equal to, it should produce equally DFT signal, that is x1 of k into x2 of k. So for this I have considered two equations, that is x1 of k and x2 of k. So I have taken x1 of k equation and x2 of k equation. Now what I am doing, I am multiplying this x1 of k into x2 of k. So multiplying, I am going to get this product. So with 1 by n. So here DFT inverse. So substituting DFT inverse x1 of k. So x1 of k, x2 of k is equal to, I'm substituting the value of x1 of k in this particular equation. So similarly, substituting the value of x2 of k, overall I'm going to get DFT inverse x1 of k is equal to, this is the product, which is fourth equation. So here I'm considering the summation k is equal to 0 to n minus 1, this one, 0 to n minus 1, I'm considering this. So instead of n minus m minus p, I'm writing qn. Instead of n minus m minus p, I'm substituting it with qn. So what I'm going to get? Summation k is equal to 0 to n minus 1 e power j 2 pi k into n minus m minus p by n is equal to. So instead of this, what I'm writing? I'm writing qn. So after this, overall, I'm writing this as summation k is equal to 0 to n minus 1 e power j 2 pi k q, because this and will get cancelled. So finally, I'm writing it as j 2 pi q whole to the power of k. So this will be equal to 1. So what I can write here? Summation k is equal to 0 to n minus 1 whole to the power of k, which will be equal to n. So this I am replacing in that summation part, and finally what I am going to get? Summation p is equal to 0 to n minus 1 x2 of p is equal to mod, that is summation m is equal to 0 to m minus 1 x2 of n minus m. So this is circularly shifted. So circularly shifted x2 of p is equal to summation m is equal to 0 to n minus 1 x2 circularly shifted how many units? N minus m units. Fine. So like this, finally what I am going to get is x1 of k into x2 of k is equal to, I am going to get the circular convolution of the two terms, which is x1 of n circular convoluted with the x2 of n. So this is the circular convolutional property. Finally, the last one, which is a Parseval's theorem, simple one. It is what it says, that the discrete Fourier transform of x1 of n should produce x1 of k. Similarly, based on this particular, the discrete Fourier transform x2 of n should produce x2 of k. So upon these two conditions, what it says, Parseval's theorem, summation n is equal to 0 to n minus 1 x1 of n into x2 convolute of n is equal to, it should produce 1 by n, summation k is equal to 0 to n minus 1 x1 of k and x2 of convolution of k. So this is the statement of the Parseval's theorem. So for this I am considering two equations, x1 of k. By the definition of x1 of k, I have taken the definition of the discrete Fourier x1 of k, and secondly I am taking the inverse discrete Fourier transform of x2 of k. So in this you can see we will have x2 of n. So what I am saying here, I am considering 1 by n summation k is equal to 0 to n minus 1. I am considering these things. So I am considering this right hand side. So and substituting the value x1 of k value I am substituting here, and x2 of k value also I am going to substitute here. So after doing the simple mathematical considerations, what I am going to get? 1 by n summation k is equal to 0 to n minus 1 x1 of k into x2 of convolution of k is equal to, I am going to get summation n is equal to 0 to n minus 1 x1 of n into x2 of circular complex conjugate of n. So simple Parseval's theorem. So these are the some different types of properties of the discrete Fourier transform. So followed by, we will take one problem related to the circular convolution. So I am considering first sequence x1 of n is equal to 0, 1, 2, 3. Okay, for this what I am writing, I am drawing one circle, and I am taking the values. I am considering this as x1 of 0, x1 of 1, x1 of 2 and x1 of 3. So total 4 values. So I am taking these values in anti-clockwise direction. Okay, I am inserting the values in anti-clockwise direction, that is x1 of 0, x1 of 1, x1 of 2 and x1 of 3. Fine. Now second sequence it is giving x2 of n is equal to 4, 5, 6, 7. Similarly, first I am drawing these same total 4 sequences it was given, and same I am drawing first this thing in anti-clockwise direction, that is x2 of 0, x2 of 1, x2 of 2 and x2 of 3. Now here comes, you can see the sequence in both x1 of n and x2 of n, the length is 4. Okay, 4 sequence given. Fine. That means we need to do it circular convolution for 4 times. M0 is equal to M1, M2 and M3. 4 times we need to shift the sequences. So first we have to keep this x1 of k in the same position, fixed position. What we need to do means we have to circularly shift in clockwise direction. You can see here. So first thing you can see here, I have drawn this in the clockwise direction. First we will keep the same thing. So first step, for m is equal to 0. So see here, this is the first circle x1 of, and this is the second circle. You can see x2 of 0, x1 of 0. It is in same first step. So what I am doing here, 0 into 0, I am going to get 0. Next 7 into 1, I am going to 7. Next 6 into 12, 12 into 2, I am going to get 12. And 3 into 15, 3 into 5, I am going to get 15. I am multiplying the two things. So see here, 4 into 0. So 4 into 0, I am going to get 0. Next, here 1 into 7, I am going to get 7. And here 6 into 2, I am going to get 12. And here 3 into 5, if multiply, I am going to get 15. This is the first step. Similarly, now I need to shift this particular second circle one step like this. If I shift that, you can see the diagram. This x2 of 0 will come here. Sorry, this x2 of 0 is coming anti-clockwise. We should shift this in anti-clockwise direction. So if we see here, x2 of 0 will be one step shifted. So x2 of 0, x2 of 1 and x2 of 2. So same, again the same process. Multiplication, we got y of n. One more shift, third step. For m is equal to 0, m is equal to 2, we are shifting one more shift. And if we see here, x2 of 0, x2 of 1, x2 of 2 and x2 of 3. It is shifted. So again I am multiplying, I am going to get another sequence y of 2. And finally, fourth step we are going to shift that. So if you see here, x2 of 0, x2 of 1, x2 of 2 and x2 of 3. And again I am multiplying. You need to keep it in mind here, the first circle should be in a fixed position and the second circle should be shifted one time anti-clockwise direction. How many times we need to do that? Depending upon the length of the sequence given. So 4 times, 4 is the length of the sequence, so we need to step 4 times. So like that, if we do all the things, what is the answer I am going to get? I am going to get y of n is equal to 34, the first step 34, 36, here the second one is 36 and third one is 34 and fourth one is 28. So the output of the circular convolution is, what I am going to get is the answer 34, 36, 34 and 28. This is one method how we need to find out the values of the circular convolution. If we take another, so this is another problem related to the circular convolution. If you see here, you can see the sequences which is somewhat unbalanced. That is, the first sequence is of 3 to 5 and second one is we have only 3. So if we get like this, we need to do the zero padding for the second one. That means these two sequence lengths should be equal. So 5 should be equal. So for that I am adding zeros, 2 added, so that the first x2 of n length will be equal to the x2 of n. See here, x1 of n is fixed and marked in the anti-clockwise. x1 circle will be fixed. We will not rotate that circle, but x2 of n is marked in the clockwise direction, but rotation will be in the anti-clockwise direction. One shift we are going to do. So here how many shift we should do means, we should do total 5 shiftings. That means we should get y of n is equal to y of 1 for the first shift, y of 2 for the second shift, y of 3 for the third shift, y of 4 for the fourth shift, and finally y of 5 for the fifth shift. This is the answer we need to get. That means 1 times 2, 3, 4, 5. After 5 shifts, for each shift we will produce y of 0 is equal to 8 for the first shift, y of 1 is equal to minus 2 for the second shifting, y of 2 is equal to minus 1 for the third shifting, y of 3 is equal to minus 4 for the fourth shifting, and finally y of 4 is equal to minus 1 for the fifth shifting. Totally how many shifts I got? 1, 2, 3, 4, 5. Total 5 shifts I got, and this is the answer what we are going to get. So this is one of the graphical representation type problem when compared to the circular. Same thing we can do in the matrix form. So matrix form, what it says. See, previously what we got the answer, you can observe here. We got 8 minus 2 minus 1 minus 4 minus 1 in the circularly representation. So please keep it in mind that the answer is 8 minus 2 minus 1, minus 4, minus 1. So same thing if I do in the matrix method, matrix representation, I should get the same answer. See here, 8 minus 2 minus 1 minus 4 minus 1. So what is the process means? Similarly, same. I got the sequence x1 of n and x2 of n, but these two are unbalanced. That is, x1 of is 5 sequences and x2 of is only 3. For that, I am adding 2 zeros for the x2 of n so that the two sequences will be equal, 5, 5. Now, what I am doing, I am taking x2 of n and I am writing that in the matrix representation. How we need to write? We need to take 1, 2, 3, 0, 0. So 1, 2, 3, 0, 0 I have written. Then next, in the next column, what should I do? This 0 will go here and again 1, 2, 3, 0. In the next column, it should go here 0, 0, 1, 2, 3. And again it should go here 3, 0, 0, 1, 2. Now finally 2 is going up and 2, 3, 0, 0, 1. Like this, how many rows we will have? We need to do like this. So see, this is the first matrix representation and this is multiplied with the x1 of n. So x1 of n we are going to multiply, and what is the answer I got? I got 8 minus 2 minus 1 minus 4 minus 1, which we have seen in the previous. That is, this is the another method to find out the value of the circular convolution. Fine, I think it is clear. Now, linear convolution using circular convolution. Based on the circular convolution, how the linear convolution is going to produce. So what is asking? Perform the following on the sequence. X of n he has given. X of n is equal to 1, 2, 3, 1 and impulse response h of n is equal to 111. And he has to find out the value of linear convolution, circular convolution, and finally linear convolution using circular convolution. Very important for the preparation of the exams, external exams which we are going to attempt, and also for the gate exams it will be very important. So first thing, how we need to find out the value by using the linear convolution. Now see here, I got the sequence x of n and impulse sequence h of n, and you can see the length of x of n is equal to, the length of the x of n is equal to, what is the length? L is equal to 4 for the sequence x of n, and the length of the sequence m is equal to 3 for h of n. So what should be the total length I need to get? So I need to get n is equal to L plus m minus 1. Very important. This is the thing. What is the final length we need to get means capital N is equal to length of the x of n plus length of the h of n minus 1. So what is the length of x of n? 4. And what is the length of the y of n? 3. So if we do that, I need to get n is equal to 6. So now here, how we need to find out the value means, just multiply the x of n with h of n. So first, 1 is multiplied with all the terms. Okay, 1 is multiplied with all the terms. So 1 1s are 1, 1 3s are 3, 1 2s are 2, 1 1s are 1. Fine. Now you need to leave this step, and with the second thing you need to multiply all the terms. Okay, so 1 1s are 1, 1 3s are 3, 1 2s are 2, 1 1s are 1. And the last, you need to remove these two spaces and find, multiply the h of n with this x of n. We are going to get 1 1s are 1, 3, 2, 1. So after doing this, just add the things 1, 3, 6, 6, 4, 1. So finally, so this is the answer. This is the y of n which is generated with the help of x of n into h of n. You can see the length. What is the length of this particular output? 1, 2, 3, 4, 5, 6. And what you got here the length? N is equal to 6. So this is the process how we need to find out the value of y of n by using the linear convolution. Similarly, circular convolution. The previous only I have shown you by using the matrix representation. We have h of n is equal to 111 only, but x of n is equal to 1, 2, 3, 1. That means 4 terms. Here 4, but here if you see here we get only 3. So for that what we have done, we have added 1 0, which is nothing but the padding. So I am adding 1 0 for the h of n to equalize both the length of the sequence x of n and h of n. Now I have taken the x of n 1, 2, 3, 1. See, I am writing 1, 2, 3, 1. So again I am taking 1 upside, 1, 1, 2, 3. Again I am taking 3 up, 3, 1, 1, 2. Again I am taking 2 up, 2, 3, 1, 1. Like this, I have framed the matrix for the x of n, and I am multiplying that matrix with h of n, that is 111, 0. If I do, I got the sequence y of n is equal to 5, 4, 6, 6. Okay, so this is the circular convolution answer. So here we will have a small thing, how we can convert the circular convolution answer into linear convolution means. So I got this answer. Which is this answer? Previously I got by using the linear convolution, I got this answer 136641. So this linear convolution, if we add the first term with the last but one term, that is 1 plus 4, and second term with the last term, that is 3 plus 4. If I add that one, what I can get here, you can see here. So y of n is equal to, I am adding the first term, that is 1, with the last but one term, that is 1 plus 4. 1 plus 4 means 5. And the second term I am adding with the last term, that is 3 plus 1 means 4. And remaining terms I am writing here same. And you can see the answer 5466, which is equal to the circular convolution. That means the answer which is formed with the linear convolution, by doing like this, we will convert this linear convolution answer into the circular convolution answer. Fine. Now finally, linear convolution using circular convolution. Same. I am padding the sequences. So how I need to do that means, first we need to see the sequence of the sequences which is given x of n and h of n. So here first thing what we have to do means, we need to check the length of the both sequence, whether the length of the both sequences are equal or not. First we know that x of n is equal to 1, 2, 3, 1 actually, and y of n value what they have given is 1. So first step what we need to do then means, we need to check the length of the two sequences, whether these sequences are equal or not. If they are not equal, what is the step what we need to do means, see here, add the m minus 1 to x of n and add l minus 1 zeros to h of n. What is m here? M is the length of the x, which we know that m is equal to length of the sequence 3, and L is equal to length of the sequence x of n, which is 4. Now what he is saying, if it is not equal, what we need to do that, m minus 1 zeros is added to x of n, and similarly L minus 1 zeros is added to h of n. How means, we know the value of m, which is the length of the sequence h of n, that is 3 minus 1 means 2. That means I am adding 2 zeros to the x of n. So what I am going to get here, x of n is equal to the original sequence 1, 2, 3, 1, and here how many zeros I am adding? 2 zeros I am adding. Similarly, L minus 1 zeros, that is, what is the length of the sequence x of n? 4. So 4 minus 1, 3. 3 zeros is added to the h of n. So what is the original sequence of h of n is 111. 1, 1, 1. So how many we need to add here? 3 zeros we need to add. Now if we compare these two sequences, you can see the length 336, 336. Fine. So first step, when you are doing the linear convolution by using the circular convolution, you need to check the length of the sequence. If it is equal, not a problem. If it is not equal, by adding these zeros, m minus 1 zeros to x of n and L minus 1 zeros to h of n, we are equalizing the length of the two sequences. So after that, the same process. Taking the x of n in the matrix representation, see, first I have written all the thing, then again 0 here, then again 0 here, 1, 3 is going up, then 2 is going up, then the remaining terms like this. Like this I have formed the matrix representation, and formed matrix representation is multiplied with h of n. So finally what the answer I got is 136641. The same thing we got in the linear convolution problem also. So this is the process how we can use the linear convolution by using the circular convolution. This is another method how we can, already I have told you how we can get the linear convolution with the sequences. See, I had given the two sequences x1 of n into x2 of n, and you can see the length, both the length are equal. x1 of the n length is 4 and x2 of n length is 4. So finally we need to find out the value of capital N, that is 4 plus 4 minus 1 is equal to 7. The answer what we are going to get, length should be equal to 7. So I have written the x1 of n into x2 of n sequence. First 4 is multiplied for all the terms. So I got 4 1s are 4, 4 2s are 8, 4 1s are 4, 4 2s are 8. Then 3 is multiplied with all the terms. So what I am going to get, 3 1s are 3, 3 2s are 6, 3 1s are 3, 3 2s are 6. Similarly, 2 is multiplied with all the factors. 2 1s are 2, 2 2s are 4, 2 1s are 2, 2 2s are 4. And finally, 1 is multiplied with all the factors, that is 1 1s are 1, 1 2s are 2, 1 1s are 1 and 1 2s are 2. So like this, after multiplying, I am going to get the sequence, this one, 2, 5, 10, 16, 12, 11, 4. So you can see here 3, 3, 6, 7. The length of the formed equation what I am going to get is 7. The length of the output what I got here is 7. Now converting the linear, so by getting the answer, I got the answer with the help of linear convolution. Then I want the same answer in the circular convolution. I told you, you consider first last 4 terms, that is 16, 12, 11, 4 will be added with the remaining terms. So remaining terms what I got here 2, 5, 10. So 16, 12, 11, 4 first I have written. Remaining terms is added with the followed terms. That means here we don't have any term. So 2, 5, 10. If I compare, if I add this particular thing, the answer what I am going to get in the circular form is 16, 14, 16, 14. So here you will get doubt, sir, whether it will be correct or not. So for this only I have taken another example. If I do the same thing in the circular form, I should get the same answer. I think you got the clarity. So linear convolution, I got the answer. With the help of this linear convolution answer, I have converted and I have found the circular convolution answer, which is 16, 14, 16, 14. So here I want to clarify, if I do the same thing in the circular form, I should get the same answer. So for that I have taken this answer. See here, circular convolution, right, last. Compute the circular convolution of x of n in x2 of n using DFT and IDFT, another method. Now, so we know that as per the property y of n is equal to x of n circular convolute with x2 of n, what I should get? I should get x1 of k into x2 of k. And this is the formula we need to keep it in mind, that is xn is equal to twiddle factor wn into xn. So here you can see the length of the sequences n is equal to 4, that is 4 is the length of the sequence if we convert, if we see. So that's why I am writing this equation as x4 is equal to w4 into x4, sorry, w4 into x4. So this is the matrix representation. First I am going to write all the x terms. How many terms I need to write? 4. That is capital X of 0, capital X of 1, capital X of 2 and capital X of 3. And I need to write small x, that is x of 0, x of 1, x of 2, x of 3. So this is the main matrix we need to keep it in mind. How we should write this twiddle factor matrix means, now here the sequence is 4. That's why you write first 0, 1, 2, 3. And vertically also you write 0, 1, 2, 3. Now 0, 0, 0, 0, 0. So you will get all zeros here. The twiddle factor with length W4. Fine. Now 1, 0, 0, 1, 1, 1, 1, 2, 2, 1, 3, 3. 2, 0, 0, 2 1s are 2, 2 2s are 4 and 2 3s are 6. And finally 3, 0, 0, 3 1s are 3, 3 2s are 6, 3 3s are 9. Like this is the matrix representation of twiddle factor for n is equal to 4. Similarly for n is equal to 8, same, you have to take 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7, but instead of 4 what you are going to write here, you will write 8. So that is the thing. First this matrix representation should be remembered by yourself. So according this, if I write the value, we will get this matrix. So W4 to the power of 1 should be equal to minus j and W4 to the power of 3 is equal to j. So and again W4 to the power of 3 is equal to j and W4 to the power of 9 is equal to minus j. Please be careful while writing this particular matrix representation when n is equal to 4. This is the fixed matrix representation. Whatever the problem you are going to do, you will get the same matrix. You need to take the same matrix representation. So what should we get for x1 of n? So now I am considering this. So x of 0, x of 1, x of 2, x of 3 with the twiddle factor matrix. I am multiplying that with x1 of n. So what I got here? 6, 0, 2, 0. Similarly, for x2 of n, for same matrix representation twiddle factor, I am multiplying with second sequence 1, 2, 3, 4. What I got here? 10 minus 2 plus 2j minus 2 and minus 2 minus 2j. So I got what I got here? I got two terms, that is x1 of n into x2 of n. Now what should I do? I need to do x1 of k into x2 of k. So finally what I am doing here x1 of k into x2 of k. So first the value, this value is nothing but x1 of k and this values is nothing but x2 of k. I am multiplying 6 into 10, 60, 0 into this one I am going to get 0, 2 into minus 2 I am going to minus 4, 0 into this one I got 0. This is the final value. Now, IDFT of x1 of k. So what I got here, this one. So if I do this IDFT, 1 by 4, twiddle factor, IDFT. So I got 1 by 4 into 56, 64, 56 and 64. If I do this multiplication, the final answer what I am going to get is 14, 16, 14, 16. You have seen the same thing previously. This one, 16, 14, 16, 14. That means linear convolution answer is converted into circular convolution. So I got the value 16, 14, 16, 14. Similarly, if I do the same thing by using DFT and IDFT, I got the same answer. So I think you got a clarity how we need to convert the linear convolution by using the circular convolution with the different models. We have done the problems. So these problems are very important for your external examinations or else for your gate examinations. So with this, I am going to end this lecture. From the next lecture, we will see the long sequence, how we need to find out the value for the long sequences by using two methods, that is overlap add method and overlap save method. Thank you so much.